Okay, there's three functions here you should have seen before. In Algebra 1, you would have talked about constant functions, so horizontal, vertical lines. You would have talked about linear functions, which is your straight lines. And you would have talked about quadratics, which is what you guys worked on yesterday. And those are the ones with the squares, the parabolas. The one that would be new to you is the one you see that looks like a V, which is the absolute value function. That is something we introduced in Algebra 2. So we've been solving absolute value equations. This guy is new for you, okay? The absolute value function. So these are the parent functions we're talking about. Constant, I think, is maybe the one that's most confusing. This is your f of x equals 1, your flat lines, okay? All right, let's fill in some blanks. The parent function, wow, why is that so aggressively large? Okay. Parent function is the most basic form of each of these. We talked about that yesterday. It's like the vanilla ice cream. It's as lame as it gets, guys. The parent function is the most basic form, and then functions can be identified by their shape, just what they look like. You'll notice they all will look kind of similar. A transformation, what we talked about yesterday. Transformation is a change to a parent function. It's a change in the size, shape, position, or orientation of the graph. And they'll either be classified as horizontal, which would be left to right, or vertical, up and down. Okay, if something is horizontal, it'll happen to just the x. If something is vertical, it'll happen to the whole function outside of the parent function. Okay, so first thing that you looked at yesterday, or maybe not the first thing actually. Yeah, this is not the first thing yesterday, but one of the things you looked at yesterday was a translation, which is a slide. That's a word that you would have seen in geometry as well. Left to right, up or down. If you have a number coming usually at the end, plus k or minus k, at the end of the function, then it would move it up or down. So a couple of examples for you. Again, you saw these yesterday. If I did something like the absolute value of x plus 2, that would move it up 2, right? Or if I have x squared minus 4, how would that move the parent function? Down 4. So these are ones that you saw yesterday. If it comes at the end, then it moves it up or down. Horizontal is your left or right when it's like in bars or in parentheses. So two examples for you. If I have, for example, x minus 2 in bars like this, that's the absolute value function. Since x minus 2, it would go right 2. That's a little bit confusing because it's kind of opposite of what you think. It's kind of like point slope form where it changes signs. And then your other example, if we had in parentheses x plus 3 squared, this moves it left 3. All right, so looking at number 1, you have the absolute value parent function, and that's a little bit obvious because you see the bars. And then you have to identify what's happening to the parent function. So if the parent function is the absolute value of x, I see in the bars now x plus 4. Which way did it move it? So it would take it left 4 because it's in the bars, and then it does the opposite of what you would think. Left or right is a little bit backwards. On number 2, you see the squared term. What's it called? Did you guys figure that one out? This is called a quadratic. That's what you did yesterday. It's the parabolas. Okay, but hopefully you know how it's moving. How's it move? Down 5. Okay, the next one, this is y equals mx plus b. So what is that third one? What will it make if you graph it? The y-intercept is 1, so this is linear. This is just y equals mx plus b, but it moves it, so which way does it move it? Up. Now we're naming them by their shape. So number 4, this is a parabola. This is again called a quadratic. If the parent function, we talked about that yesterday, if the parent function starts at 0, 0, then it was moved in which direction? That's what you need to think about. So can you look at numbers 4, 5, and 6 now, discuss what are those, and then how did it move? You're not sure what. Okay, number 4, on number 4, which direction, if it started at 0, 0, it moved which way? Left. How much? 1. Whoops, forgot the T. Left 1. Okay, next one, number 5. This is a line. So what do we call it? Linear. It's a linear function, and linear functions, again, you're starting with the y-intercept at 0, 0, so it moved down how much? Or you could have said, which other way could you have said it moved? Right. So it's actually going to be the same thing for linear functions. If that's confusing to you, then you can stick with down. And then number 6, that's a V shape, so that's your absolute value, which is what's new for you. And again, it would start at 0, 0, but then it moves up, I think 4. Okay, if it's f of x and then minus 2, how do you move the graph? Down 2, because it's that k value after. So this one needs to be taken down 2, and you're going to use this graph that you see right here actually. So we're going to take each of those points and move them down 2. So just like you did like in geometry, right? You just move them all the same direction. So take each point, move it down 2, and then you'll connect your lines. Or sorry, connect your dots to make the same shape. Can you please talk with your table? How do you move the next one? And then you can move each point. 3, up, 1. Does that look right? Just the translations, which are shifting, left, right, up, down. Okay, you have the reflection, which is a flip of the graph. We're only going to talk about vertical reflections, so reflecting over the x-axis, where you have a negative sign in front of the function. Here's 2 examples. If you have, I don't know, negative in front of the absolute value, or like we did yesterday, negative x squared. Both of these would flip it over the x-axis and make it reflect. Okay, your first one, if you were confused on how to figure out the parent function, okay, it's not quadratic, because quadratics have a squared. It's not absolute value, because that has the bars, so that only leaves you with constant and linear. Which one is it? So constants only have a number. If you look back at page 6, constants are just like y equals 2, y equals 1, y equals 7. This one is linear because it's mx plus b. Linear functions do not have an exponent, or you could think that they have an exponent of 1. So this is linear. If you were to graph this, or think about if I graph this right now, what will it look like? It will look like a line. So that's what it is. and then negative x, so again, that's just an x-axis reflection. Or reflecting over the x-axis, if that helps you. Okay, this next one hopefully is a little bit easier. You've got bars. What is it? Absolute value. And again, you have the negative in front, so it reflects over the x-axis. I'll say it a different way this time. Number 10 is a parabola. We call that quadratic. And again, these are all the same. They reflect. They just flip. So you see some random f of x function, I think it's the same one we used in the previous page. Describe the transformation, and then sketch the graph. So you see the negative in front, that means you're going to reflect it over the x-axis. So it flips. So just like you did in geometry, you take each point, and this is my x-axis here. So you need to reflect it over that line and flip it to the other side. So you need to count like how many squares away. So 1, 2. So it needs to go 2 the other way so that it flips over the axis onto the other side. So right there. It's 1 away here, so it goes 1 the other way. And it's just like flip-flopping. And you connect it. Should be the same graph, just flipped.